very first video, I'm going to introduce chemistry. So, what is chemistry? So, chemistry is the study of matter. Then, what is matter? So, matter is anything that occupies space, or in other words, volume, has to have some kind of volume, and has mass. So, for example, you yourself is a matter because you occupy some volume and you have a mass. And your desk, your cell phone, pencil, pretty much everything that you see in daily life are matter because most of them occupy space and has mass. Even air occupies space and it has mass. Before we move on to next vocabulary, I want to differentiate the mass and weight a little bit. Because a lot of time people incorrectly use those two words, but we have to be specific in science courses. And I want you to be able to differentiate between these two. So mass is the quantity of a matter that a substance, any substance possesses. So if you are 100 pounds in the earth, you will be 100 pounds in the space as well because it's independent of the gravity. But weight is a little different. If we go to the space, then we're gonna be floating in the air, right? Because the gravity is much lesser. If you get into the water, your weight may feel different as well. When we talk about weight, we have to consider gravity as well. So we can actually calculate the weight, including concept of gravity. It's W and mass as M. Okay, weight is equal to gravity times mass. So G stands for gravity or gravitational force. So we should be able to differentiate between mass and the weight. But in chemistry, we don't want to deal with the gravity so much, so we're going to mainly focus on mass. Okay, because mass doesn't really change, or property of the mass to resist a change of a position or motion is called inertia. Basically resists. In chemistry, when we say something is inert, that means it's not reactive. It'll be very stable. It's not going to react with other substances. That's what it means when we talk about inert or inertia. Since matter does occupy space and it has mass, we want to explain the relation between space and mass. So the relationship of mass to the unit volume is called density, or we're going to just use capital D for that. So we can calculate density by doing mass over volume. In chemistry, a lot of times you're going to just use gram as a unit for the mass, and we are going to use centimeter cube or milliliter or liter for the unit of volume. Density simply explains how dense the substance is. So if you compare, for example, gold versus styrofoam, gold is much denser. That's why it's heavier with the same volume, right? As compared to styrofoam. Every single substance has a specific number of density at specific temperature and pressure. So at given temperature and pressure, density is constant. It doesn't change the number. Let's talk about the states of a matter a little bit. So there are three states of a matter: solid, liquid, and gas. Let's think about something very simple and easy like water and ice. Ice is the solid form of water, and the water is the liquid form, and the vapor, gas form, right? Solid, as you can make gas, has definite size and shape. It has a size and it has a shape. But on the liquid, they have some kind of volume but has no shape. And for the gas, doesn't have a shape and it doesn't have a volume either. These states of matter can be changed as well if you change the temperature or pressure. When we change solid to liquid, the reaction is called melting, like from ice to water. And if we change liquid to gas, we call that evaporation. And gas to solid, that's deposition. And we can also change liquid to solid, like water to ice, that is called freezing. And gas to liquid, called condensation. And solid to gas, that is called sublimation. I know these vocabularies are a little too much for the beginners. You probably know melting and freezing already, probably know evaporation, but if you're not familiar with the condensation, sublimation, and deposition, then just try to be familiar with it for now. I'm going to repeat it when it comes back, okay? So don't worry too much about it. All right, so these are the 3 states of a matter that we're going to talk about. As I mentioned before, we can change solid to liquid to gas by changing the temperature and pressure. And we are going to talk about that as well. Let's get into matter a little bit more. So matter can be divided into 2 types. So mixture and pure substance. And for the mixture, we also have 2 different types of a mixture. One is homogeneous mixture, the other one is heterogeneous mixture. And for the pure substances, we have a compound and element, okay? So let's talk about mixture first. As you can probably guess, mixture is something that is mixed together, okay? If there's no layer, if you cannot tell what's in there, then that's homogeneous mixture. For example, think about adding salt in the water. If you dissolve salt completely in the water, you cannot really tell what's in the liquid, right? What's in the water unless you taste it. So that is the example of a homogeneous mixture. Salt water, sugar with water, that's all homogeneous mixture. And the heterogeneous mixture, something that you can see different layers and you see like different textures and things like that. So for example, if you mix with water and oil, they're not gonna mix completely, right? So we are going to have 2 different layers, one layer for water and the other layer for the oil. So that is the example of a heterogeneous mixture. Chocolate cookies. You're gonna see a chocolate part and cookie part, right? So they're mixed together. They're like one chunk, but you can clearly see the different layer or texture. That's heterogeneous mixture. Pure substance, we have 2 different types of a pure substance. One is the compound and the other one is the element. Let's talk about element first. So element is something like composed of one type. For example, gold. Well, in chemistry, we're going to use Au for the gold. Sodium. Anything that you can see from periodic table, we're going to talk about periodic table later on, but if you're familiar with the periodic table, anything that you see in the periodic table are elements. So that's a pure substance. It's not mixed with anything. It's just solely one type of substance. What would be the other example? Hydrogen, fluorine, and chlorine. And example of a compound will be something like water. Chemistry, we're going to write water, H2O. That means in order to form one water molecule, we have to have 2 hydrogen and 1 oxygen. Sodium chloride, glucose. Glucose is like a sugar, and sodium chloride is a salt, and water is like that. So in order to form a salt, sodium chloride, we have to have 1 sodium and 1 chloride. For glucose, we have to have 6 carbon, 12 hydrogen, 6 oxygen, and so on and so forth. Do you see that? Then here, question. For oxygen that we inhale every day, we write O2 in chemistry. Then is it element or compound? We have to have 2 of oxygen in order to make 1 air molecule. Since it is composed of only 1 type, which is oxygen here, that will be element. It's not compound. So in order to be a compound, we have to have 2 or more different elements mixed together. Then what's the difference between mixture and compound? Both of them looks like they're mixture of 2 or more different things. Let's say I have in this container, circle and triangle mixed together. Every circle, 2 triangle attached to it. This is an example of a mixture, and that's example of a compound. So the biggest difference between these two is that for the mixture, you don't have to have a specific ratio. You can have 10 circle, 5 triangle, or 5 circle and 2 triangle. It doesn't really matter. But for the compound, you have to have a specific ratio. So every 1 circle, we have to have a 2 triangle. Like for example here in water, every 2 hydrogen, we have to have 1 oxygen. If we have like 3 hydrogen and 1 oxygen, that's not water. It's not water. So in order to be water, it has to have 2 hydrogen and 1 oxygen. So it has a specific ratio to it. That's one big difference between compound and mixture. So for the compound, by the law of a definite composition or proportion, they have to have specific ratio to each other.